In 90% of the situations we're going to see, the intervals of continuity can be found much more easily than what we did before with sketching the graph. It turns out that almost every function we're going to see in first year calculus can be thought of using intervals of continuity using this theorem. This theorem covers pretty much any function you're going to see in first year calculus that is not a piecewise function. There will be functions which are not piecewise functions, which will not be covered by this theorem, that you may cover if you do more studies in math, more studies in computer science. But for first year calculus purposes, this function is pretty much exhaustive. When it says that any polynomial, rational, algebraic, trigonometric, exponential, or logarithmic function is continuous on its domain, it's basically going to be continuous wherever it is defined. Which means that if you want to find the intervals of continuity, all you need to do is find the function's domain. This makes it very easy to find intervals of continuity, provided that the function is not a piecewise function. On this slide, I've got two examples of functions which are not piecewise, and therefore their continuity can be found using their domain. So this first example, we want to find the intervals of continuity of this function. So the first thing to do is we want to find the domain of the function. The fact that there is a square root of x tells you that x has got to be bigger than or equal to 0. The fact there's an x minus 1 on the bottom tells you that x cannot equal 1. So the domain is going to be the numbers between 0 and 1 together with the ones between 1 and infinity. Again, 1 is not included in either of those intervals. So this is the domain. This domain contains two intervals. Each of those is an interval of continuity. So I can say now that the intervals of continuity are 0 to 1 and 1 to infinity. So finding the intervals of continuity is as simple as finding the domain of the function. In this example here, we want to figure out where the function is discontinuous, which means we want to figure out where the holes are in the domain. Well, the domain here is going to be the restriction that the bottom of this fraction, x squared minus 3x plus 2, cannot be 0. If we factor this polynomial, we get x minus 2 times x minus 1 cannot be 0, which means that x cannot be 2 and x cannot be 1. So 2 and 1 are the two holes in the domain, which means this function is going to be discontinuous at x equals 2 and at x equals 1. The holes in the domain give you the discontinuities of the function.